What's up, everyone? I feel like it's been ages since I live streamed. I think I kind of took 2 weeks off, but it's good to be back. And it's kind of sad. This is the last section of the Elixir Getting Started guide, but we'll figure out some more documentation to read for these live streams because I think it's pretty fun. Maybe we'll do Phoenix or something like that next. But today, we are going to be doing the debugging section. And this is actually pretty cool because I feel like I was just glancing at this before I hit the live button, and a lot of it I don't really use in the real world. I'm a big IO puts, and I do use inspect, but there's some cool stuff in here, so I think we'll all learn something and it'll be a lot of fun. So with that being said, let's go ahead and jump in, and I will open up Safari. And we're going to go to elixirlang.org. Let me make this full screen. It's probably good. And then we're going to go to guides, and we're going to scroll down to debugging. And here is... Look, this is so sad. I think this is like our 24th or 25th video, and we did it all. That's kind of cool. All right, so debugging. There are a number of ways to debug code in Elixir. In this chapter, we will cover some of the more common ways of doing so. IO.inspect arity2. What makes IO.inspect arity2 really useful in debugging is that it returns the item argument passed to it without affecting the behavior of the original code. So let's see an example. Here, we're passing in a range, 1 to 10, and then they're inspecting it at every what would we, oh my gosh, I'm blanking on, why does my brain not work? Well, anyways, they're inspecting it between every function, between all these pipe operators. So let's go ahead and pull up our terminal. And I'll make this bigger for us. Transforming, that's the damn word I was looking for. So they're inspecting between every transformation of the variable being passed through. All right, so back to our terminal. I'm going to start our IEx shell here. And let's see, we're going to pass in a range here. So we're doing 1.10, so 1 through 10. How can I do this? We'll just do 1.10, and then we'll just pipe all in a line here in our IEx shell. And then if we do IO.inspect, and then pipe in, now we're going to do enum.map, and we're going to do, so each variable we're pulling out, so 1 through 10, and we're just multiplying it by 2 here. And okay, so that's 1, and then we're going to inspect this again, IO.inspect. And remember, as we pipe in, inspect is taking a single argument, right? So it's taking whatever output we're getting from each of these transformations. And then after we map through and multiply it, we want the sum of everything, and then we're going to IO.inspect that. So now when I hit enter, maybe, let's see, do I have to just do, is that all I have to do? We might have to just write a function and call it. I don't know how to write a range in the IEx shell. Or do I have to call the module? Maybe I have to call the module. Yeah. Let's see. Is undefined or private? Oh, I have a typo. Inspect. Here we go. There we go. All right. So I'm going to just clear this. It's annoying me that it's at the bottom. All right, so we have our range. So first we're inspecting our range, right? And then we're inspecting that. So we see that here. And then we're mapping through that range and multiplying each item, each value by 2. And then we're inspecting that. And you'll see our list of all of our values. So 1 through 10, all multiplied by 2, which is cool. And then we're taking the sum of all those values and inspecting that. And we see that here. And then obviously we get our output, which we would get even without the inspect there. So that's pretty cool. And so that is IO.inspect. And let's go ahead and as we saw that it printed all these things. And as you can see, IO.inspect arity2 makes it possible to spy on values almost anywhere in your code without altering the result, making it very helpful inside of pipeline like in the above case. IO.inspect arity2 also provides the ability to decorate the output with a label option. The label will be printed before the inspect item. All right, so this is pretty cool. We can pass in a second variable called label, and we can put whatever value we want there. So if we go back to our terminal, and let's see, I'm going to just alter this guy. And if we go through all of our inspects, so I'm going to, right here, we're going to say label, and then we'll say before. And then we're going to go after our map here, label, after. All right, and we'll copy the example here, and we'll get rid of that last inspect. So it just will return sum. And when we hit enter, you'll see our label. So we know that before was our range here, and then our after is the list of transformed values from our range put into a list. And then obviously the sum is returned to us. So that's pretty cool. It's also very common to use IO.inspect arity2 with binding arity0, which returns all variable names and their values. All right, so let's see, inspect binding. So if we create some function here, we pass in 3 arguments, and then we say IO.inspect binding. Let's see, with some fun. All right, so let's go ahead and just create a new project so we can copy the example. So I'm going to just CD to my desktop, and we'll say mix new, and we'll call it debugging. And then we'll CD into debugging, and then we'll open this up with VS Code. We'll close that welcome screen, and then we'll just go into the debugging.ex file here. And now we're going to, we'll delete this, and we'll just create a function. We'll say def sum function, okay? And then we're passing in A, B, and C arguments. And then inside of this, we're just going to say IO.inspect. And then we're going to pass in binding, arity0 there. And then we'll just return an OK atom. So our function returns something. So now if we go back to our terminal and let's see, mix dash capital S, wait, let me think, IEx dash capital S mix, there we go. And now if we go to debugging, capital, it's the module, and then sum function, and now we have to pass in 3 parameters, right? And what we can do here is we'll just copy this example. We'll say foo, and then we'll pass in a string bar, and then another atom baz, and then when we hit enter here, you see that our inspect binding shows the arguments passed in. So A was a value of atom foo, B was a value, a string bar, and then C was a value atom baz. So that's pretty neat. And back to the documentation. So you can see that inspect arity2 and inspect.options respectively to learn more about the function and read about all that is inspected. So C, oh, I see. They're directing us to more documentation. So if you want to check more of that out, obviously go look at the inspect function in the documentation, and then you can also see what options can be passed in. So that's pretty nice. I mean, I love Elixir documentation. It's pretty well done. Hey, what's up, Polar Bear? Welcome. Good to have you here. Let's see if, whoops, I didn't mean to show my face. Huge. It doesn't look like chat is going to work today. So annoying. But anyways, all right, back to documentation. Whoops. Good. All right. So then there's debug arity2. In Elixir version, I agree, Ben, completely. It really is, because look at this. It's just all right here, and it's beautiful. So then we have debug arity2. And so since Elixir version 1.14 introduced this, debug is similar to IO.inspect arity2, but specifically tailored for debugging. It prints the value passed to it and returns it just like IO.inspect, but it also prints the code and location. Okay, so this is pretty cool. So if we, let's see, how are they doing this example? So in my file.ex, we have a feature, and then we're going to say debug feature, and then let's see, put the code above prints this. Okay, so let's go ahead and go back into our function here. And if we go ahead and let's see, I want to just think about this for a second. Should I just put this in the module so it automatically runs, or should we run it? No, we'll make a new function. So we're going to call this debug, if I can type, debug, and we're not going to pass in any variables here, so we'll just do this, and we'll do the same example here. So we'll say feature equals, and we'll pass in a map, name, debug as a value, and then inspiration, Rust. Okay, so we have our feature, and then we're going to call debug, and we're going to pass in that map. Okay, and then we can also debug our map put, and it looks like we're going to add another value to our feature map, and we're going to be adding a key called inversion, and that is in 1.14.0. Okay, so we have our nice little function here, and then I'm just going to return an atom, so our function returns something, and when we recompile this, so save this, and let's go back into, I'm going to just clear this so we can see, and then if I recompile, and we call this function, so we have our debugging module, and I think we have our debug function. When I hit enter, you're going to see that debugging. So we have, let's see, it tells us what file we're in. So we're in the lib directory, the debugging.ex, and then on line 14, so right here, line 14 is where our first little debug is being called. All right. And it is debugging, let's see. So when that gets called, we're debugging our feature, and then it's showing us the map of what feature is. So that's really neat. And then we're debugging our map.put, and that tells us that's happening on line 15 inside of our debug functionality 0, just like up above. And then it's showing us that we're doing a map put. We're passing in our map feature and inserting our inversion. And then it's showing us the results from that, which is our updated map with inversion. And then obviously we were returning our OK tuple. So that's pretty cool. Super useful to know that you're debugging the correct line, right? So if you're trying to track a bunch of, so like what I said, I use a lot of IO puts, and then I'll like inspect maps and things in that. But what's hard with that is if you're not putting labels on everything, you might forget where you have your puts. And at least with this, it's telling you exactly what line you're running the debug function on, which is really cool. All right, back to, all right. When talking about IO.inspect arity2, we mentioned its usefulness when placed between steps of pipelines. Now this debug does it better. It understands Elixir code, so it will print values at every step of the pipeline. So like when we did the IO.inspect, we were putting it in between things, right? With this, we just had to put it at the end, and it will debug the whole pipeline, which is pretty cool. Let's go ahead and pull back our, oh, did I close? I closed. I was going to say, let's go back to our original example, but I can just write that out. So we're going to do our range with values 1 through 10. And instead of inspecting here, we're just going to say enum.map and function x. And then we're just going to say x times 2. And then we're going to pipe and say enum.sum. And then all we're going to do at the end here is do our little debug, just like that. And when we hit enter, we get a breakdown of every line with just doing that once. So we see that it's in our IEx shell from line 5. That's pretty cool. And then it shows our range, the value of our range, which is 1 through 10. And then it shows that we're doing an enum map. And what we're doing is we're multiplying each value by 2. And then what we're getting returned is a list of every value now doubled. And then we're calling enum sum, and we're getting our value back. So debug is pretty cool. And I'm going to start using this because I waste so much time doing IO puts and typing in like silly messages so I know exactly where it is. But this is pretty nice. And you get pretty detailed breakdown, which is pretty cool. All right, back to, all right, so while debug provides conveniences around Elixir constructs, you will need IEx if you want to execute code and set breakpoints while debugging. Pry, so when using IEx, you may pass 2 flags in, or options. You can pass in debug pry as an option to stop the code execution where the debug call is. So that's really cool. So we can start IEx debug pry, or if we were, so what we should do is rerun our shell in the project we just created, and we'll pass in debug pry, and then it will stop at debug. All right, so let's try this. I want to just, where's my VS Code? Okay, so if we call our debug function here, it should do a breakpoint here, and then we'll have to manually continue, and then a breakpoint here. So that's really cool. Let's try that. All right, we got to close our shell. I'm going to clear this so we can see again. And what we need to do is we need to start our shell now. So we have to do IEx, and then we have to pass in debug with the value pry -s mix. So all we're doing different here is passing in this value and then hit enter. And now when we hit, let's see, debugging.debug, when I hit enter, okay, breakpoint reached. So let's see here, breakpoint reached debug on 14. So it spit out our whole function. Let me just see how this, let's go back to, All right, so now you can call, now any call to debug will ask you if you want to pry the existing code. If you accept, you'll be able to access variables as well as imports and alias from the code directly from IEx. This is called prying. While the pry session is running, the code execution stops until C for continue or N for next are called. Remember, you can always run IEx in the context of a project with IEx mixed task. Okay. So let's see. Request pry. Let's see how this example plays out. I'll make this full screen. Can you guys see? I've been relying on inspect 2, but yeah, I agree, Max. It's really cool. All right, so we're going to watch this little pry example video so we know what we're doing. IEx debug.exs. Okay. Let's see. Allow, yes. Okay. Let's go back to our shell. And now if I hit C to continue. Okay, cool. So it does stop at each debug as a breakpoint. That's really cool. So we stopped at line 14. And let's look at line 14. That should print out our map without the inversion. And then when I hit continue, it spit that out, which is really neat. And then it stopped at the next debug. Oh, you can kind of see it's slightly bold here. Okay. And then it stopped at our next debug. And then let's see, if I hit C, it'll spit out that value. And then it returns our OK atom and is finished. That's really neat. So that is how you can do breakpoints with pry. Let's read. Let's continue reading. Or I shouldn't say breakpoints. When using IEx.pry stops code execution because now, okay, DBG calls require us to change the code. So breakpoints, whoops, I'm clicking all over the place. So breakpoints, DBG calls require us to change the code we intend to debug and has limited stepping functionality. Luckily, IEx also provides IEx break, Arity2 function, which allows you to set and manage breakpoints on any Elixir code without modifying its source. Okay, that's really cool. Let's watch this video. Okay, we start an IEx shell, and then they're typing in break exclamation URI decode query Arity2. Okay, so they're adding a breakpoint to that function, and then they're calling that function to pass in foo equals bar, and then a breakpoint is reached. Where am I? And then it's telling them where the breakpoint is, URI.ex file on line 136. Okay, and then where am I? Line 20. And then query map. Okay, so you have access to the variables that you're looking at. All right. IEx code. All right, similar to DBG, once a breakpoint is reached, code execution stops until you continue with C or next with N are invoked. Breakpoints can navigate line by default. However, they do not have access to aliases and imports when breakpoints are set on compiled modules. All right. Let's see. The mixed test task direct integration with breakpoints via the -b or --breakpoints flag. When the flag is used, a breakpoint is set at the beginning of every test that will run. All right, that's cool. So let's see. Let's clear this, and then I got to close out of this. how do I... All right, so if we do IEx-s mix test -- breakpoints, and then this will debug. Okay, so if we do failed -- failed, it will debug all failed tests. There are no tests to run. Where's our, let's see, we have our test, debugging tests. Okay. Let's see, mix, let's close out of this. Let's do mix tests, mix test, undefined function, debugging hello. Okay, so we have a failure because we have a test that doesn't exist. So if we, let's see, debug, we'll just call our debug function here. And that should equal an atom OK. And this runs our debug function. Save that, and then mix test runs our tests. Okay, so now how do we... All right, debug the test at any given line. Okay, now let's see, line 6. Line 6. Okay, we're going to IEx-s mix test-b, and then the path to our test would be test-debugging test, and then line, what line did I say? 6. Okay, sweet. All right, so we just hit a breakpoint and it stopped on our assert debugging equals OK. So now if I hit next, it finishes, it moves on, and it printed out, let's see, it printed out our debugging on line 14. Oh, that's the actual function, our debug function's being called. But after the breakpoint, it went ahead and finished, and our test passed because we got OK. So I'm going to make this, let's see, not OK. Not OK, because obviously our function returns OK. And if we start this now, if we say -b failed, oh, I need 2 dashes. There are no tests to run. Path. Maybe, wait, let's see. IEx mix test, IEx-s mix test -b failed. I don't know why that's not working, but if we run, let's see, close out of that. If we run, I wonder, instead of, if we just pass in the path like this, if we do failed on this, no. I don't know what's going on here. But we can do our breakpoints on a given line of a file, which is pretty neat. Maybe I'm just, oh, and then now our test failed when I hit next because the right side is not OK and the left side equals the OK atom. But maybe I'm just doing something wrong here. I'm like half showing you how the breakpoints work, but I've never used breakpoints in an IEx shell. I've always used my IDE for breakpoints. So this is kind of cool. Maybe it's something I use. No need for debugging if you write perfect code. Yeah, exactly, Rodrigo. I wish we could all write perfect code. All right, so let's see. We'll move on from that. I think that's really cool. We know how to breakpoint on a specific line, and you can do that on probably any path to any file. So it doesn't have to necessarily be our test. So then there's the observer. For debugging complex system, jumping at the code is not enough. It is necessary to have an understanding of the whole virtual machine, processes, applications, as well as set up tracing mechanisms. Luckily, this can be achieved in Erlang with the observer in your application. All right, so we have to start this. Let's see. Let's pull up our IEx shell. And now we have to, let's see. So we say mix.ensure application and then observer. Okay. And then if we do observer.start. All right, there we go. And that launches our observer GUI, which is really neat. And this allows you to see how many atoms exist. 3% are used. How many processes are currently running? What ports are being used? Your ETS, so your why am I blanking? Basically your onboard tables. We went over this last time. Why can't I think of what it stands for? Erlang libraries, term storage. So that's pretty cool. Back to, let's see. So the above will open a graphical user interface that provides many panes to fully understand and navigate the runtime of your project. We explore the observer in the context of an actual project in the dynamic supervisor chapter of the mix and OTP guide. Maybe that's what we'll do next, is the mix and OTP guide. That would be a lot of fun. This is one of the debugging techniques that the Phoenix framework used to achieve the 2 million connections on a single machine. If you are using the Phoenix framework, it ships with the Phoenix Live dashboard, a web dashboard for production nodes which provides similar features to Observer. All right, so let's go ahead and just play around and look through this a little more. So you guys can see a lot of cool stuff, and you can see load charts, memory allocators. So really neat applications. So this is kind of cool. This will show you all your applications, like the root project, our supervisor running, XUnit server, our capture server, and then you can see all the processes running with the PID IDs or the process IDs. So that's neat. And then our ports, sockets, table viewer, and all right. So we'll go through this in the mix and OTP section, right? And maybe we'll learn a little more details about this, but that's pretty cool. All right, let's see. Finally remember, where did I leave off? Finally, remember you can get a mini overview of the runtime info by calling runtime info directly in the IEx shell. All right, so if we do runtime info, there we go. We get a mini overview of what that GUI just showed us. So the observer, and then here's a summarized version of that. Super helpful. And if you're ever dynamically creating atoms, you'll probably see a big problem right here. You don't want to do that. Okay, so other tools and community. We have just scratched the surface of what the Erlang VM has to offer. For example, alongside the Observer application, Erlang also includes a crash dump viewer to view crash dumps, integration with OS level tracers such as Linux Trace Toolkit, dtrace, and System Tap. Microstate accounting measures how much time the runtime spends in several low-level tasks in a short time interval. And then mix ships with many tasks under the profile namespace, such as mix profile cprof and mix profile.fprof. For more advanced use cases, we recommend the excellent Erlang in Anger, which is available as a free ebook. Let's check that out. Stuff goes bad, Erlang in Anger. Cool. check that out, guys. It seems like a pretty good read. So that is the last section of the Elixir Getting Started guide. That's kind of sad. This was fun. I'm glad that I started doing these live streams, and I think we'll just continue with going through more guides, because I personally learn a lot just reading through them. I just learned some awesome debugging techniques. And yeah, thank you for everyone that tuned in. I appreciate you guys, and I'll see you guys in my next live stream.